Hello, everyone. I'm Chong from Monash University, and I'd like to present our work today entitled Assessing the Students' Understanding and Their Mistake in Code Review Checklist, an experience report of 1,791 code review checklist questions from 394 students. Joining me today is Pete from the UC of Melbourne and also Clara from Monash University. So first of all, I'd like to discuss about the motivation of our work. We would like to investigate how can we actually improve the way code review is taught in universities. So I think it's widely acknowledged that code review is one of the most powerful and reliable way for software developers to identify potential software defects before the code is pushed to the source code repository. However, teaching code review is still a very challenging task, mainly because the effectiveness of code review heavily relies on the experience, analytical skills, and also reading skills of the reviewer, or in our case, the students. So we found that checklist-based code review can be one of the valuable way for students, especially inexperienced students, to learn how code review can be conducted, because the checklist encourage the students to focus on important issues or defects during their evaluation. So on the right-hand side is an example of the Google's engineering practice documentation, where the reviewer are provided with some question, focus on some specific defects. So checklist-based code review, although it is useful, it might not facilitate development of the students' analytical skills to anticipate potential issues. This is because if we were to provide the checklist to the students might just follow it blindly, and it might limit their creativity, and they might not think out of the box. So worse is that the students might not even understand or appreciate the key motivation behind the checklist-based code review exercise. So another problem that we identify is that generally in the industry, senior software developers, they don't really have a physical code review checklist. Instead, the reviewer, they have to depend on their own experience and knowledge when they're performing a code review. So basically, they are just fusing their own mental checklist when they're performing code review. So in this research, we want to investigate, can we actually get the students to develop their own checklist? And this might be able to help stimulate their critical thinking skills. However, we are still unclear whether the students can predict potential issues when they are preparing the code review checklist, and also whether these checklists prepared by the students, are they actually useful or not? So these are the two research questions that we'd like to investigate. The first one is, to what degree the checklist prepared by the students can be used to identify defects during code review? By answering this question, we might be able to get some idea whether or not getting the students to create their own checklist can be part of the syllabus when we are offering code review related subjects to the students in a university environment. The second question is, what are the common mistakes in students' checklists? By answering the second question, the educators can help identify or address the potential mistakes or misunderstandings when the students are preparing the code review in order to facilitate the learning process. So we have prepared a code review assignment in the following manner in order to answer the two questions. First of all, the students are given requirement specification and screen mockup of a particular case study. So this is an example where we have provided some software requirement specification followed by the screen mockup. Following that, students are required to create and submit their code review checklist based on the artifacts given to them. Okay, so this is an example of the code review checklist submitted by the students. They can put it into different category if they want to, but each of the checklist question is in a question format. So based on that, they'll be given the actual code artifacts to be reviewed. So these code are actually embedded with some defects, and students are required to prepare a list of identified issues based on their own checklist created in step 2. Finally, they will be discussing in a group to discuss whether or not these defects that they have identified, are they actually false alarm or are they actually genuine defects? So they get to take turn and defend their findings. So this is the analysis result. We actually performed the study across 2 campuses, one in Malaysia and one in Australia. And it spans across 2 years, 2018 and 19. We got a total of 1,791 questions from 394 students across the 2 study cohorts. So in order to answer research question 1, which is to what degree can the student's checklist be used to identify defects during code review, we analyze the type of defects that the questions prepared by the students by trying to categorizing them into different taxonomy, into taxonomy. So this taxonomy was actually proposed by Mantilla, and Mantilla actually proposed a taxonomy of defects where the authors categorize the defects into categories such as documentation defects, visual defects, structural defects, and so on. So if the checklist question prepared by the students are indeed useful, they should be able to put into either one of these category of defects. So we use this taxonomy proposed by Mantilla, and we actually perform manual coding among all the authors. So as a result, we found that 76% of the checklist question can indeed be used to identify defects, or more specifically, 70% of the checklist question that produced by the students are actually very clear and can be used to guide reviewers to identify the common defects. So this is a breakdown of the results that we have got. So you can see that most of the students actually focus more towards obvious defects, such as structural defects and also documentation defects, not much on the large defects. That helps answer the first question, research question, where we identify that indeed there is a large amount of, which is 76% of the checklist question can actually be used to identify defects. And with regards to the second research question, what are the common mistakes in the student checklist? We have identified 425 inappropriate checklist questions, which is 26% of all the checklist questions. So most of these checklist questions are unclear and irrelevant. So this partly stems from the misconception about the quality specification of the code review checklist. We found that some of the students are focusing on testing related checklist question and also static analysis related checklist question. So these are not really suitable when we are performing code review. So these issues can be addressed, and we think that it can be modeled as a scaffolding activity where we actually can get the students to demonstrate their understanding of code review by getting them to develop their own checklist. Following that, educators can understand the misconception among the students, and then from there, we focus some certain guidance to correct their misconception. And this can be an iterative process to help improve the way how code review can be conducted in university environment. So that's all for our presentation. Thank you very much.
It was frozen.
On my side, it is showing that we are now live.
In my side, it says it's frozen. You are not.
Okay.
Okay. Hello, everybody. Sorry for the technical issues. Okay, we are in the QA session of the third paper of this first session of the educational track of software engineering. So we have Chun, that is here, is one of the authors, and he will be happy to answer and discuss your questions. So while the different attendees raise their questions, I have a couple of questions. The first one is about the artifact that you provide to the students so they can identify the different mistakes. So is the same artifact for all the students?
Yeah.
Can you discuss a little bit about it? How big is this artifact? How do you choose it? Why do you choose this specific artifact, and so on?
Yeah. So basically, we give the students the first artifact that we give the requirement specification. So it outlines what the system is supposed to have, what the functionalities that it's supposed to have. So the artifact is the same for all students. And then apart from the software requirement specification, we also provide screen mockups to show the interface of the system. So of course, we purposely make it such that they are the issues so that the requirements and the screen mockup, some of them are not tally. Okay, so students will be given the information that this app will be application. So based on their understanding or knowledge, they will need to prepare the checklist items based on the requirements and provided to them to mimic that students are performing a review on an app with the given.
And how size is this specification? Approximately, I mean, how many requirements, or it's just to have an idea of which is the effort that they have to do in understanding the specification and preparing the checklist?
If I'm not mistaken, the requirement specification is only about 2 to 3 pages. I think it is around 10 to 15 requirements, function requirements that the students need to address. Yep.
Okay. Okay. Then I have another comment that is when students prepare the checklist, they use this checklist to measure the quality of the product. So they are obtaining the mistakes that they are performing. So I think that is an important added value from your experience, because this gives the opportunity to the students to learn from their own mistakes.
Yep.
Do you have any information from the students or any feedback from the students about what do they think about this? They identify some mistakes that they thought they were not mistake, or what? Do you have information about this?
Yep. So the way that when the student first prepare their own checklist items, they are doing it individually. So once all the students have prepared their own individual list, we actually perform a group inspection. So during the group discussion, each and every student will actually turn to discuss about the checklist items and also the mistakes or the bugs that they have identified using their own checklist item. So we have a discussion during the group discussion where students start to realize that, oh, some of the defects or the bugs that I identify are actually a feature. They are actually not a bug. So it helps spark a lot of critical thinking, the group discussion, and students found that there are several they got wrong when they are preparing the checklist item, and things that they felt that is a bug is actually not a bug. So the most common one that we identify is that some students actually thought that they actually need to identify like typo errors, syntax errors, stuff, where syntax error typically can be automatically checked by a lot of modern IDEs. So yeah, then got.
And do you give the students any guideline in order to create this checklist, or they just do it?
Yep, they do it
as they understand.
Yep. First of all, when they prepare their own checklist, they do it based on their own understanding. But after they have submitted their checklist, after they have done their group discussion, we do mark the part of the assignment. So we will give some, letting them know that you have actually made certain mistakes when you are preparing the checklist item. So based on the feedbacks, then they further improve it from there.
Okay, there is one question from Elke. Probably we have already talked about this, but I will read it in any case. Did you also consider reviews of checklists across the different students group, such that the students try to understand and assess the checklist of others?
So during the discussion, where in group, students have the chance to join other group discussion as well. At the end, we also discuss some of the major mistakes students have made, and also some of the good things that students have identified. So it helps students to check in between groups what are the good practices and what are the common mistakes in the groups as well. Yes, we do provide opportunity for students to do that as well.
Okay. And then I had another question about the incorrect questions in the checklist. If you could explain a little bit which kind of issues do you identify there?
We do a checklist that is or incorrect and such. So these are the they are unclear. That some students prepare a checklist questions asking that, is this code maintainable? So of course, maintain subjective thing. We can't really measure it directly. So this is, and a lot of students actually come up with checklist questions related to software testing. Like for instance, does the code pass the unit testing, pass the integration testing or system testing? Well, this is where the misconception comes in the picture, where they thought that during code review, they also need to check on the software testing part, where so we could help provide some guidance, letting the student understand that. So software testing can be automated, run by certain test code, and whereas the code review activity performing some like a sanity check and looking at a different perspective of the quality of the code rather than the integration test. So yeah, so those are the examples of irrelevant checklist questions that we have identified.
Okay. Okay, there is a question from Natalia. She said that we are experiencing issues with the author's audio. Maybe we can switch his camera off. Okay.
Okay.
So, Chun, okay. Okay, thank you, Chun. Thank you. Okay, I have another question. Is that once that you have finished this experience, okay, for these years that you have performed it, what would you do different if you have to repeat it in another edition? What would you change?
Yeah, so if we were to do it differently, I think we will try to test it on different cohorts of students. So in this paper where we report our result, the students are actually second-year students where they have only attended 2 to 3 programming subjects, and they have a pretty limited knowledge about programming and so on. While we do get pretty good results, 70% of checklists are usable, we would like to look at when we use the same approach or a slightly enhanced approach, what will happen if the students are final year students where they are in third year or even in the first year, to look at a broader perspective of how can we improve the way code review can be taught in university environment. So I think this is something that we would like to explore as well.
Okay, thank you very much, Chan. We have 10 seconds left, so I think we don't have more time to questions. So thank you, and thank you.
Thanks everyone, and thanks
Bye.
Anna.
Thanks.
Bye.
Bye.